Hello, my name is Garrett, and in this Unity tutorial we're going to be talking about baked lighting. So what is baked lighting? Baked lighting is a form of lighting that is applied to a scene or baked into a scene using a light map. We can think of a light map as kind of like a texture, meaning that it is pre-rendered and doesn't have to be continuously generated during runtime. So on the left here is an image of a scene with some lighting, and on the right is the light map that's actually generated and put on top of this scene. So that means the lighting doesn't have to be continuously generated for this scene, it's just always going to be there. So because it's kind of like a texture, it cannot be disabled during runtime, and it can only be applied to objects that won't move, otherwise known as static objects. So here on the right we can see an example of a baked light where maybe it shouldn't have been baked, because even though the light was able to be shot out, you can see how it gets black in the middle when he shoots it. Its emission did not change at all. So that's how we know it's definitely a baked light. So why would we use baked lighting then? Why would we use this lighting that isn't that flexible in our scene? Well, definitely the biggest reason why developers would use baked lighting is to give us better performance during runtime. So because all of the light is pre-computed in baked lighting, it spares the computer from constantly doing complex equations in order to display the light in real time. So this brings the additional benefit of allowing very complex and detailed lighting in the scenes, like the lighting that we see in these scenes right here. Because these lights are baked into the scene, they become easy to generate when it's ran on other computers and devices. So as far as practical uses go, almost any light source or emission could be baked into a scene. It just has to be static. You should really always consider baking lighting, since it's only going to make your game run smoother in the end. Consider it when possible anyway. So take the scene down here, as long as you don't have a lot of moving objects or players or NPCs in this area, you really don't have to worry about shadows or the lights changing in any way. So all these lights could potentially be baked as long as that's the case. And that would definitely make your game run smoother if it doesn't have to constantly generate those lights. Alright, so here's just a few more examples of lights that could be baked into our scene. So like lights that are out of the way are detail lights, and by that I mean just lights like these. Here's a bunker in GTA, and these lights obviously aren't going to be casting shadows and they're not going to be changing, so those could easily be baked, especially on those walls around them. Or like detail lights over here, just kind of adding some extra color. This is Fallout New Vegas, and so these lights, they aren't going to be changing in any way, so those could be baked. TV screens and monitors are great examples because they do cast light, and it does add to the scene when we see that light on the walls around it, but obviously they're not bright enough to really cast shadows or anything like that. Maybe if you want your TV to be shot out, you wouldn't want it to be baked, but if that's not the case, then I mean, baking it would be fine. Same thing with glowing signs, like again down here in Fallout. This might be a bad example because Fallout has a daylight cycle, so these turn off in the day. But if that wasn't the case and these were always going to be on and it was always going to be dark, then these would be great for baking because it would save you all that processing power during runtime. So lastly, we see Unity used a lot in mobile games. So it's important to note that baked lighting can actually be ideal for mobile devices since they don't have the same processing power as like a computer or an Xbox. So if you have dynamic lighting, which is non-baked lighting, real-time lighting, if you have dynamic lighting in mobile games, you're probably going to lose a lot of frames per second because the phone won't be able to keep up with generating those lights. So for mobile games, baked lighting is kind of a necessary. Take this little game down here. This is a 2D game, which I'm not exactly sure how lighting in 2D games work, but if this was a 3D game, this is something we could light very easily. There's no shadows. It doesn't look like the lighting would ever change that much. So this could definitely be a baked light in this example. So that should do it for the presentation. I'm going to move over to Unity now, and let's take a look at that. Alright, so here we are in Unity. You'll notice that my scene already looks pretty different from the default scene. That's mostly because baked lighting takes a long time to generate. So I already generated all of my baked lighting examples in this scene, but I will be retracing my steps just to show you the process I went through. So first, we're going to pull up the light settings, which is right under that window tab there. And I'm going to go ahead and drop it here because we'll be using it a lot. So the first thing we want to do is I'm just going to get rid of the skybox material. You can do that by clicking none, and that's just going to get rid of a lot of skybox light that it produces. I'm also going to put the ambient color of the environment lighting to black. I'm going to turn real-time global illumination off because I only want to look at baked lighting in this example. Make sure the light mapper is on progressive CPU. It should default to it. Enlighten is the old version, which just isn't that good. Make sure you enable ambient lighting. Ambient occlusion, which is right here. It's basically just going to make the lighting look a lot more realistic with realistic shadows and stuff. And then finally, turn off auto generate next to generate lighting so that it doesn't constantly try to generate all the lighting changes we're going to be making. I also increased my light map resolution and my padding as well as the number of bounces. You can do that too, just keep in mind that it's going to take a lot longer to generate the higher those settings are. If you just want a rough idea of what baked lighting is going to look like, then you can keep these settings relatively low. Okay, let's move over to our scene now. And I'm going to make a room because I feel like that's a really easy way just to show lighting. So we're going to start off by making a plane. Make sure you have this enabled because your scene is probably going to be pretty dark without it. I'm going to duplicate this plane a few times. This first plane over here, this is going to be our left wall. This next one will be our right wall. This next plane is going to be our back wall. This plane right here will be our ceiling. And finally, this last plane will be the front wall. Alright, cool. So now we have a room. Why don't we put some stuff in the room to light up? So I'm going to start with a cube. Put it like right about there. Put a capsule in there. Kind of right in the middle. And then I'll put a sphere in there. Just so we can see how the lighting looks on different shapes. Okay. And actually, let's color these things too. So I already have some materials made down here. Let's make the cube green. Make the capsule red. And we'll make the sphere blue. So now let's get to some lighting. For this first one, let's just do a simple point light. I'm going to put it right in the middle of the room. And we're going to put its mode to baked. So if we try to generate the lighting right now, it's probably not going to work. And there's a pretty good reason for that. You'll recall that all the objects need to be static. So some of these are static right now. It must be because of what I duplicated. But just make sure that this checkbox right here is static. Alright, so now you'll be ready to go down here and hit generate lighting. So I have already done that. So let's take a look at this first scene. Here's the room I generated the lighting in. I'm going to hit this so that we see what it actually looks like. I can also turn on the camera in it just to see more. So you'll notice this is definitely baked lighting because if we move a floor, these shadows will move right along with it. And no matter how far away we move this floor from the light source, the floor is always going to look like it's illuminated. So this is a pretty basic example of baked lighting. Why don't we make it a little more complex and let's do some emission lighting instead. So I'm going to go back to the room here. I'm going to turn on this again so we can see what we're doing. Go ahead and turn off this point light. We'll probably use it again later. And let's add some more planes. Make these planes a little bit smaller. And I'm just going to position them right on the sides of the room. Okay, so now I've got my two planes in place. I'm going to put a texture on each of the planes. So on this one on the right, I'm just going to put this purple emission texture, and the one on the left, I'm going to put this yellow emission texture. So something important is we have to make sure that our emission is set to baked. And we also have to make sure again that these two objects are both set to static. Alright, so we're now ready to bake our lighting again. And so I already have this pre-baked. So I'm going to go ahead and turn that off. And let's go to this room. Line view 2 selected, and here we are. So this is what this room would look like. Can turn on the camera too. We can see the cube is kind of dark because of its color. And again, we'll notice that if we move the floor, the emissions move right along with it. The shadows of the objects are pretty soft. That tends to be how the emissions create shadows, especially when they're colored. So now let's take a look at a scene with a combination of emission light and that point light again. So back to our little plane over here. Go ahead and turn on that again. I'm going to reactivate the point light, and I'm also going to give it a color this time. Let's go with like blue. Cool. Make sure it's still set to baked and that the light is still static. And again, we are ready to generate this scene. Alright, so here is what that room is going to look like. We'll notice that it is. Gotta turn that off. So that is what that room is going to look like. We'll notice we have a very unique blend of colors here. The cube, again, is very dark. I think that's just because of the way the colors mix onto its color. You'll notice on the side where color is yellow, it tends to stand out a bit, but on the other side, it gets really dark. So these shadows are still baked into the floor. They move wherever the floor moves. And so this would be an example of just kind of a combination of lights that are baked into a scene. It looks pretty good, and there's no distortion within the scene. So let's talk about distortion for a second now that we have a scene with some complex lighting. So I also baked these scenes previously in lower quality settings just to get an example of what they would look like. And you'll notice they don't look nearly as good. Especially even in this first picture, you can see these little lines right here. Those are some light distortion. Same with these little spots on the cube along the capsule. And we've got some in this picture, especially on the capsule. Same with our last one, again on the capsule. And also the cube was even way more dark in this picture. So this was at the scene, the quality light map resolution was at 20, the padding was at 2, and the number of bounces was at 2. So when you are ready to finalize any project you're working on, I highly recommend bumping these settings up. Again, if you're just going to get a feel of what your baked lighting will look like, then you can leave them relatively low. But once you bump them up, it will mostly get rid of all those little distortion and glitches, and if it doesn't, then just bump them up higher, really. It's just the best way to fix any distortion you might have within your scene. Alright, so next I'm going to touch on mixed lighting for just a bit. So this is a combination of real-time lighting and baked lighting. I thought it was pretty cool, so I wanted to look at it here. So let's go back to our scene, turn on this again, and I'm going to go ahead and get rid of our two emission planes. I'm going to put our point light back to white, and I'm going to put it on mixed. Again, everything should still be static, and we are now ready to generate again. So let's see what that looks like. So here's what this mixed light is going to look like. I can turn on the camera for it. Just like that. So this light has some unique properties to it. So if we move around the floor this time, you'll notice these shadows don't move with the floor. However, if we take the floor away, we'll notice that it still looks lit up no matter how far away it is from the light. That is kind of how a mixed light works pretty much. Okay, so the next thing I want to look at is some baked lighting and a few more practical examples. So down here I have some things that I imported from the asset store. These are just some sample scenes. Here we are in the scene. When I first opened this scene, none of these lights were baked. They were all set to real time. And so I just kind of went through and decided which lights could be baked and which ones couldn't, just to show you that you really don't need to have all these lights in here set to real time. So first off, let's take a look at these lights down here. You can see these lights are baked. If I move them around, nothing changes, right? So these lights I kind of just decided, they look like they're kind of part of this little machine here. So they're really not going to be essential. They're not going to need to be adaptive. They're not casting shadows. So those are easy examples of baked lights. I have these lights labeled detail lights, like over here. This light had cast shadows turned off initially. So because it doesn't need to be adaptive in any way, that's an easy baked light right there. Same with this one up here in the corner. Nobody's going to have any shadows up there, so that's another baked light. And then these four lights, these are where the bulk of the lighting in this scene is coming from. If I was to turn them off, the scene would get pretty dark, just like that. So in this case, you would not want to bake these lights, just because if you have a player walking around in this scene, these are lights that they're going to have shadows casted from, right? So I put these lights on mixed instead. So if I have something in my scene, say like a cube, you can see that cube has a shadow because of the mixed lights around it. However, these mixed lights still have a light map baked onto all of the textures around them, which saves us that little bit of processing power during runtime. And one more thing I put inside of this scene over here is this nice television with a giraffe on it. This is another thing I got from the asset store. So this television, it has an emission on it. Here are the settings of that emission here. So you can see I have it on baked, obviously. Both of the picture and there's the emission color. So this is giving off some emission. We can just kind of see that on the walls around it. But obviously, since it's not very bright, it's just a TV. Doesn't need to be adaptive. It could easily just be baked into the scene instead, just to save us all that processing power. If you were to have like a player with a gun in the scene, and you wanted this TV to be able to be shot out, then you wouldn't want to do that. You'd want to have that a real-time light, just so that it has that adaptability. But in this case, it doesn't really. I had pictured this scene as, I don't know, just the player walking around and exploring. So having a TV be able to be shot out or be adaptive isn't really that important in this context. I just want to mention again really quickly the presence of light glitches. So you probably noticed in this scene there's actually a ton. Like, this is not what real lighting looks like, right? So again, I had to export this at some pretty not so great settings. 40 for the resolution, 4 for the padding, and then 2 bounces. And that still took my computer about 3 hours to do. So just keep that in mind, that if you do have light glitches in your scene, you can always just bump up these settings and that will get rid of them pretty easily. Just keep in mind it's going to take a while to bake. Alright, so there's one more thing I wanted to mention as far as baked lighting goes. In order for light to be baked onto an object, it has to have light map UVs. These can be added in sculpting software like Blender, but if you don't want to do that, if you're just importing stuff from the asset store and you need to have its own light map UVs on it, what you'd want to do is when you import something to your scene, so here I have just this, it's called ring truss. You want to click on it in your assets folder and scroll down right here to generate light map UVs, and Unity will make its own light map UV for it. So anything that you create in Unity will have light map UVs already on it, like this cube. Most stuff you get from the asset store will too, but if it doesn't, then you can have Unity generate its own, which usually works pretty well. Alright, so that should be all for this lighting tutorial, baked lighting tutorial in Unity. Thanks for watching.